Okay. Derivative of exponential function, something other than e. So if I have the derivative of a to the x, then that's going to be a to the x times ln of a, where ln of the base, okay? Just like e to the x, if there's something up there besides x, you have to do the chain rule. So if you want to think about a compound function, like the derivative of a to the u, where u is a function, would be still a to the u times ln of a times u prime. Right? That's the chain rule, so I don't know if you want to, I don't think about it as a separate rule, but you can if you want. So why didn't we do this with e? Well, hopefully you realize we don't need to do that with e, and I'm just going to do one of these to show you. Well, it says, find f prime of x applying the rule that we learned from the previous section. So the previous section, we would have said e to the cosine of 2x times the derivative of cosine of 2x is negative sine of 2x times the derivative of 2x would be 2. So that would be negative 2 e to the cosine of 2x times sine of 2x. What if we use the rule that we did up here? Well, I'm going to leave it as e to the cosine of 2x times the ln of the base, which is e, times the derivative of cosine of 2x, which is still going to be negative 2 sine of 2x. But remember what ln of e is. ln of e is 1, so that's why you get the same answer as over here, because ln of e is just 1. So it's not necessary, okay? That's why we don't do it. This is not a huge topic on the AP exam, so I'm not going to do every single one of these, but I do want to practice a few with you. I'm going to scroll down because my videos are cutting off the bottom now. So that's kind of messy, but I believe it says 4 to the x squared. F of x equals 4 to the x squared. So f prime of x is going to be 4 to the x squared times ln of 4 times the derivative of x squared, which is 2x. You cannot multiply this times the 4 because the x squared is there. There's not really a whole lot you can do on these, which is why I think it's not a huge topic, which means I'm just going to leave it like that. If I do the next one, what rule would I have to do here? I'd have to do the product rule, right? So g prime of x, the derivative of x squared is 2x times 2 to the 2x. And again, that's not 4x because the 2 to the 2x is separate. Plus, leave the x squared alone. And the derivative of 2 to the 2x would be 2 to the 2x times ln of 2 times the derivative of 2x, which is 2. So I think maybe I could factor a little bit out on this one. What could I do? I could factor out the 2 to the 2x, right? That takes care of both of those. I'm just going to do that and leave what's left, because that would leave me 2x plus 2x squared ln of 2, which means you really could factor out a 2 and an x as well, but I don't know. It's a mess. I can't do anything with it. So I'm going to leave the other ones here. Like this one's kind of just like this, and this one is a product rule. We're not subtracting one from the exponent when we do that because it's a function up there, right? So let's do some uglier ones here. Gross. Okay. If I do this top one here, what rule am I going to have to do? I'm going to have to do the product rule, the chain rule, and the derivative of the exponential here. So the derivative of 2 to the negative theta is going to be 2 to the negative theta times ln of 2. And the derivative of negative theta is just negative 1. So I'm just going to put a negative in front times cosine of pi theta plus, but I think it's going to change to a minus, but I'm going to leave it plus for now. Leave this one alone. And then the derivative of cosine of pi theta is going to be negative sine. So I'm going to change that to negative sine of pi theta times the derivative of pi theta would just be pi. So times pi. Again, I don't really enjoy these so much because there's not a whole lot of simplifying that can happen, and it just kind of looks messy. We could factor the 2 negative theta out, but not much else happening here. Let's do one with the quotient rule, and then I'll move on to the logarithms. I don't know which one. They're about the same, so let's just do this one. If I do the quotient rule here, the derivative of the top is going to be 3 to the 5x times ln of 3, and then the derivative of 5x is 5, so then times 5. I'm not going to do this one, so I'm going to run over into this box a little bit. Minus the derivative of x on the bottom is just 1, so times 3 to the 5x all over the bottom squared, which is x squared. Again, there's not much you could do here. We could factor out the 3 to the 5x, and I'd be left with 5 ln of 3 minus 1 over x squared. But nothing simplifies on that, right? It's just kind of messy. All right, let's look at the bottom one here. It says, for what values of x would the graph of p of x equals 2 to the negative 3x have a normal line whose slope is 2? Show your work and explain your reasoning. So if the normal line has a slope of 2, that means the tangent line has a slope of negative 1/2. So we want to show where does the derivative equal negative 1/2. So to take the derivative of this, that would be 2 to the negative 3x times ln of 2 times negative 3. And I want to know where does that equal negative 1/2. This is terrible. So where does 2 to the negative 3x, I could divide that over and say negative 1/2 over ln of 2 times negative 3. I think I would use my calculator here. Maybe I could even just graph this and set it equal to negative 1/2 and see where it equals, right? Remind me in class, we'll use our calculators to see where that works, okay? Gross. Okay, and then the other thing, ln shows up. E and ln show up all over the test. Log base a and a to the x, not so much, but I'm going to show it to you anyway. So if I have the derivative of log base a of x, then the derivative is 1 over x times ln of a. And again, why doesn't this apply to ln? Because ln of e is 1, okay? So remember that ln of x is the same as log base e of x. So I'm not going to do both of these, but if you did this using this rule on the bottom of your fraction, the derivative of ln of x would be 1 over x ln of e, and ln of e is just 1. So again, with ln, it's not required to do this. With other bases, it is. And just like with the other ones, they don't work out really nice. You just kind of get a mess. So again, let's do a couple and then move on from this. So if I was going to do the derivative of log base 2 of 4x, then the derivative is, again, I don't know if you need the u stuff in there. If it was the derivative of log base a of u, then you would have to do u prime over u ln of a. So don't forget the chain rule, okay? That's how I kind of think about it, is just using the chain rule. So on the bottom here, I need ln of 2 because that's my base. This is like my u, so I need a 4x on the bottom. And then the derivative of 4x is 4. So then I actually can cancel those 4's out, and I would get 1 over x ln of 2 as my derivative. What about this one? So on the top, I need the derivative of sine of x, which is cosine of x. On the bottom, I need sine of x, and then ln of 3. Could you simplify that? Well, cosine over sine is cotangent, so that's really like cotangent of x over ln of 3 is the same thing. Again, still kind of messy. What else do I have? Lots of uglier ones, right? Where's my time? 9 minutes. Okay. I'm going to move on to the uglier ones. Gosh. What about a couple of these with quotient rule and lots of messy here? Let's try this one. So The derivative of the inside is going to go on here. So that's going to be cosine of x squared times the derivative of x squared is 2x. On the bottom, I would have sine of x squared times ln of 2. So again, cosine over sine is cotangent, so this will be the same as cotangent of x squared. I'm going to put the 2x in front. 2x times cotangent of x squared over ln of 2. I can't cancel these 2's out because the ln is connected to the 2. Let's do this mess because it's a quotient rule. So the bottom would be this, right? The bottom would be 3x over x minus 1 times ln of 3. The top would be the derivative of that, which would be the quotient rule, which would be 3 times x minus 1 minus 3x times 1, right? All over x minus 1 squared. So cleaning that up, this would be 3x minus 3 minus 3x on the top. So I think I just get negative 3 over x minus 1 squared. This is just all multiplication, so I don't have to get a common denominator. That's just like 3x ln of 3 all over x minus 1. Since it's not squared, I would invert and multiply here. So I would flip this up and make that x minus 1 over 3x ln of 3, right? And then I could cancel this out with one of these. I could even cancel this negative 3 out with this 3. So I think I get just negative 1 on the top over x ln of 3 times x minus 1. Again, not a huge topic on the test, okay? And then we'll look at this one too with the calculator. See maybe if you can set it up to do this. Hopefully.